So in this video, I'm going to go over how to do the Coloring Moles lab. So if you noticed, my box where I have my little mole guy, that's what he was supposed to be, is all colored in. So what you are going to do is pretty simple. You're going to take a crayon, which is paraffin wax, and you are going to weigh that crayon. Now, attached to this lab, I have a picture of the crayon being weighed, both before and after the coloring. So you are going to weigh the crayon before you color. You're going to weigh the crayon after the coloring, or I'm going to, I should say. And then you are going to subtract those two weights to get the mass of the wax that is actually on the paper, meaning whatever left the crayon must be on this paper. So that's going to give me my mass of, that's going to give me number 2, and number 4. Now for the GFM of the crayon, you're going to, or the formula, the chemical formula for paraffin wax is right up here, C25H52, so that should be pretty easy to figure out. And then you are going to calculate the mass of the paraffin wax on the paper by subtracting the before and after. Then you're going to turn that into moles of paraffin wax, meaning I know how many grams of paraffin wax are on this page now, and then I know the GFM for paraffin wax, so I can calculate the number of moles for paraffin wax that went onto the page. That should be pretty easy. And then number 7, you're going to take your answer to number 6 and multiply it by the amount of molecules or particles in a mole, which is 6.02 times 10 to the 23. So you figure out how many moles of paraffin you have on the page, multiply by 6.02 times 10 to the 23, and that'll tell you the number of molecules that are in this entire box. Now for number 8, I'm going to include a picture of the length and the width with a ruler. So you're going to get the length and the width off the ruler, multiply them together. That gives me my area in square centimeters. So that gives me my area. And then if I take my number of molecules, which is my answer to 7, and divide by my area, which is my answer to 8, I will get the number of molecules per square centimeter. So a square centimeter is a tiny little bit. It's probably like only this big. I'm just estimating, but that's a square centimeter, right? Somewhere around there. And so that little square that's going to tell me, or the answer to number 9 is going to tell me how many molecules of paraffin wax are in this tiny little square over here. That's a square centimeter. So you're going to be that's actually the whole first page. And then when we get to the second page, you're going to be doing basically the same questions. So there are some different. So 1, 2, and 3 are just review questions. They're pretty easy. Is paraffin wax ionic or covalent? How do you know? You should know this. Number 2, does it have a higher or low melting point? That's based off our properties of ionic and covalent compounds. So you can go back to the notes for that. And will it conduct electricity? That's also in the same notes about what you need in order to be able to conduct, and if paraffin wax meets the 2 requirements needed to conduct electricity. 4 and 5, you're going to do the same thing that you did in 7, 8, and 9, but you're going to do it for the entire crayon. So for number 4, you're going to figure out how many moles of paraffin wax were in the entire crayon before you colored. So you're going to take the weight of the crayon before you did any of the coloring, so it's the very first crayon weight, and then figure out how many moles of paraffin that is. We're going to ignore the wrapper, obviously. And then number 5 says how many molecules would be in the entire crayon before coloring. So what you're going to do is you're going to take, there's actually a mistake here. So we're going to take our answer to number 4, which is from this page, and just multiply it by 6.02 times 10 to the 23, and that'll tell me how many molecules of paraffin wax are in the entire crayon before I colored. All right, and that's all you have to do for number 5. That's going to be a big number, obviously. It's not as big in terms of molecules. They can get much larger than that, but as far as numbers that we're used to using, that's going to be should be the biggest number on this page. And then there's just a little picture at the end that's really nothing more than a joke. How to make a mountain out of a molehill, because you get it, he's a mole. And that's everything you need to know for this lab.